Robotics system. Today I'm going to show you one of the most important thing of the real world application in Docker, and is running Intel RealSense D435i with ROS2 completely out of the box. So without fighting with drivers, firmware, version, dependencies, wrapper, and so on and so forth. If you like this kind of content, don't forget to subscribe to the channel, hit the notification bell in order to do not miss the next topic that I'm always dealing with robotics, simulation, industrial application with robotics integrated in with the computer vision. So first of all, let's talk about the problem. I'm doing this case with a real sense depth camera, but the concept are extended to all sensor that might have a complex setup. Why I'm saying that? Because if we wanted to work with a real sense camera, this is going to be a very complex software, because you will need to install on your system the driver and librealsense the driver. Then you and then it can work standalone in your machine. But then if you want to this sensor in a ROS2 environment, you install a wrapper, and you might have experienced a problem in binding a certain version of the driver of the software with a certain version of the wrapper. The wrapper, in short term, is a software that makes the bridge between the driver and the software application layer like ROS2. So it's thanks to the wrapper that we are able to stream an image on a certain kind of topic like camera slash image raw, etc. And all these pieces, which is going to be the LibrealSense and the wrapper, needs to work together in nested, and together needs to work with a specific version of the hardware. So the LibrealSense works exactly for a specific version of D435, but it can be different from D455. And the same situation is that you're going to have a different kind of wrapper that works only with a specific kind of driver and hardware, so it can be a mess, and we're gonna see in a while. So what it would be nice to have is to take the RealSense depth camera, plug it into your computer or in your Jetson, for example, if you're going to deploy into a edge device, and start it right away out of the box without any increasing with the installation, setup, and so on and so forth. And that's why Docker comes to help us. So what we're gonna deal with is exactly this application. So this is exactly what we are going to do. We're going to use a Docker image provided by NVIDIA. We are pulling in our computer. We run this container with the RealSense plugged in our computer, and you will see how easy it is. Okay, so the first things that you to get is the right Docker image. So the first thing that you need to run into this website. I'm gonna put the link in the description down below. And then you just need to follow this procedure. As you can see here, this method works with this hardware, and in particular, I'm having this type of Intel RealSense. And then here you can see here that there's going to be a different version of drivers and wrapper. So just to let you know, the wrapper is something like this. And I just wanted to open up to show you that sometimes it can be a mess. So you can see here that you're going to have the official Intel RealSense ROS2 wrapper, and you are going to have a different distribution and different branches, and each branches goes with a specific driver of Intel RealSense and with a specific type of Intel RealSense. And a traditional method, if you wanted to hack your system, it will be to download the libreal sensor, then download the wrapper, make sure that this version fits, and then run it on your system. Okay, and then if you want, you can follow these instruction. Okay, to make sure that you are going to deploy the camera in your system. Okay, I'm gonna put this link in the description down below. Okay, so first, what we need to do is to follow this command. I already did it previously. Tried to follow exactly this. I just wanted to mention what I did. So the first things that you need is to create as an environmental variable this variable here, which is binded to a specific folder of system. Okay, and in order to set this up, you just need to click this developer environment setup. There we go, and here you can see what you if you wanted to deploy the camera on a Jetson platform or in a workstation. In my case, it's going to be this platform x85, 86. Okay, so you just need to install this, the container. I'm not going to do because I already did it. And then restart Docker, just copy and paste this command. It's going to be very easy. Okay, and now you just need to create a ROS2 workspace. Wanted to experiment it with Isaac ROS. We are going to talk about Isaac ROS in the upcoming video. But for now, just keep with me for the moment, just trust me. And here you are going to create this folder inside your machine. So if I go inside my system, this is exactly what I did. So to check, I want you to see that if I go in the workspace folder, then what I'm gonna have, this is Isaac ROS and then SRC. Okay, so this folder is binded with an environmental variable Isaac ROS workspace, and I have sourced this in the bashrc file of my computers in such a way that whenever I open a terminal, this export is done automatically. Okay, so now that's why we can use the following command. Okay, so after that you did this, you just need to go inside this folder, the SRC, and then clone this. So if I let's say copy this, it's just to show you that I did it already. So if you can see here that I'm gonna have, I have already cloned this GitHub repository with this specific release. So in this case, just follow the NVIDIA tutorial, okay? Don't reinvent the wheel, okay? And then here you can see that I have cloned already this RealSense ROS, which is gonna be the wrapper. Okay, so the first thing is going to be the driver, okay, that put in your system your computer with the hardware, the camera, which is this one, and then if you want to have this camera to talk in the same language that ROS2 can process, you need to install this specific wrapper. Okay, and we have seen it that is going to be you can see here that is not included here. Okay, but basically the approach is going to be the same. Okay. Then here you need to copy and paste the command, and this allows you to configure your ROS-dev sh. Basically, if you have followed the last video, the ROS-dev is going to be a very complex script that recognize automatically the system that you are working with already, and choose what is going to be um, the target image that you need to run. Okay, and this is very important. Okay, so now uh, what we can see here is to copy this command, and uh, and this allows us to go inside the container. So we can just um, open a terminal and copy exactly this. So there we go. So it's running the script, running basically the run dev sh. We are not going into detail. We are done in detail in the masterclass. By the way, check the link in the description down below. And then here we are inside the container. Okay, and then what we can do is just take our camera, I'm going to plug it in, and I'm going to plug the USB cable. There we go. So now what I'm going to do is to put the embedded software created by RealSense. So it's going to be RealSense. There we go. So this software is working inside the container. Okay. So if I put here, so I switch to RGB camera. Let's see. Okay, 2D. There we go. So this. There we go. So this is the camera, and then basically what you can do is to switch to 3D, and then just um, use the and play with it with the 3D image. Okay, there we go. So basically, this is going to be points. Okay, so basically that's it. So this is um, the um, the setup that I've done in order to use out of the box this complex sensor using Docker. Okay, and this is the first part of this tutorial. Now we have our RealSense camera that is working inside the container. Okay, so now let's use this container with ROS2. So now what you need to do in order to use this camera in a ROS2 environment is to paste, source the environment, and then try to launch the ROS launch file that is launching all topics that are available for this camera, okay? And thanks to the wrapper. So we need to run ROS2, then launch, then the name of the package is going to be RealSense camera, if I remember correctly, and then the name of the file is going to be RS launch. Okay, there we go. Now there are some parameters that we can play with that are embedded to the camera. For example, we can enable the points clouds. Okay, and in order to do this, you just need to type this point cloud point enable. Okay, trust me. If you want to go in the detail of how to play with the camera, this is a topic that I'm dealing in depth in the masterclass. I'm gonna put again the link in the description down below. So then here, what is happening? Now the camera is publishing all the topic available in ROS2 for this camera. So if I open under terminal and I run ROS2 topic, okay, you're gonna see that these are all the topics available thanks to the fact that we have launched our camera inside the container, everything inside the container. And in fact, if we run rvis 2, okay, on the host, pay attention, okay. Now I set up a camera link here. The fact that the host can see the topics provided by the camera is because I have set up the ROS domain ID as an environmental variable. So the host and the container share the same ROS domain ID number. Okay, this is very important, bear in mind. So if I add here, I wanted to publish, let's say, a point to cloud, and then I can see it should be available the topic provided from the camera. There we go, and there it is. So I'm here. This is a point. So this is exactly what we had in the with the software of the RealSense, but this time the 3D image that we are going to see is inside the Docker container and is expressed in a way that ROS2 can actually handle thanks to these topics. And this is thanks to the wrapper that we have used right away using Docker. Okay, so that was all for today. I hope that you enjoyed this video. We have learned how to exploit a very useful functionality of Docker, which is running a complex hardware out of the box. If you like this video, make sure to subscribe to the channel, hit the notification bell. If you want to master your career being a robotics software engineer, check out the link in the description down below, where you can see here the curriculum, which is specifically designed for giving you a hands-on approach in industrial robotics using and integrated with a vision system from software to a hardware point of view. Again, thanks for your attention, and as always, learning robotics with ROS.